Let's jump right into this explainer because today we are talking about a massive, fundamental shift in how we actually view the law. I mean, think about it. For centuries, our idea of law has been completely static, right? We literally picture heavy, dusty books, endless stacks of paper jammed into manila folders, dead ink on dead trees. It's totally passive. But today, we're smashing that old paradigm. We are exploring what it looks like when we move away from static paper and step into a world where the law is an active, executing, computational performance. So let's get into it. Here's our roadmap for today. 1. From paper to performance. 2. The software runtime paradigm. 3. Roots of legal engineering. 4. Decoupling logic from data. And 5. The 3 stages of law. We're not just looking at a syllabus here. We're charting a journey from the analog past straight into an autonomous, executing future. All right, section 1, from paper to performance. I want you to genuinely imagine this for a second. What if an agreement wasn't just something you filed away in a cabinet until, something went wrong? What if instead it was a living, breathing entity? This is the core mindset shift we absolutely have to make. We're moving from a static view of legal documents to a dynamic calculus mindset. In a day-to-day context, this means you aren't just drafting rules for humans to hopefully follow later. You're writing strict instructions that a system actively carries out right now. We have to start seeing legal instructions as an actual active performance. And that brings us to a really critical definition, the runtime. In computer science, a runtime is the active execution environment where instructions are dynamically performed. Basically, this is where the magic happens. When you write a computational contract, it doesn't just sit there waiting for someone to read it. It lives in a runtime. It breathes. Imagine a commercial contract that knows exactly when a payment is late because it's securely wired into a banking API, right? And it just automatically applies a fee or triggers a breach notification with zero human intervention. It checks conditions, moves assets, and executes instructions entirely on its own. Moving on to section 2, the software runtime paradigm. Think about the traditional legal concept of a performance, the actual fulfilling of contractual obligations by the parties, like handing over the keys to a house or making that scheduled payment. Now, compare that to a software runtime, the execution of programmatic instructions by a computer. Here is the mind-blowing part. Conceptually, they are fundamentally the exact same thing. A software runtime is simply the active execution environment where your legal performance actually plays out. The contract is no longer just a description of the performance, it literally is the performance itself. This brings us to what the sources brilliantly call the composer metaphor. A lawyer's job is shifting from being a simple scribe to being a musical composer. Think about how profound that is for a second. Step 1, you design the entire system beforehand. You write the verses, you write the choruses, you set up the conditional loops. Step 2, you hit play. And step 3, you just step back and watch the stage performance execute autonomously from start to finish. Why is this so much more powerful? Because as a composer, you are no longer reacting to breaches of contract after the fact. You are orchestrating a system where breaches are either computationally impossible to begin with, or they're instantly resolved by the very code you wrote. You aren't micromanaging the actors anymore. You orchestrated the entire runtime. Section 3, Roots of Legal Engineering. Now, you might be thinking this all sounds super futuristic, but this paradigm shift is actually the very foundation of the digital world we already live in. Take Charles Goldfarb. He's often called the grandfather of the internet, and he literally created markup language, the precursor to HTML, which structures everything you see on the web today, by digitizing traditional legal redline drafting techniques. He took the way lawyers physically strike through and insert text and turned it into semantic tags that a computer could instantly understand. Wild, right? And Nick Szabo, he designed the foundational concept of smart contracts by looking at the traditional legal requirement of consideration, the necessary exchange of value to make a contract binding. He ensured that this core legal concept was hard-coded into cryptography to incentivize decentralized network validators. Our entire digital infrastructure was basically architected by translating legal concepts into computer science. But actually teaching this new paradigm to modern practitioners, it's not easy. As Kyle Smith from the Lex Clinic notes, we'll find out we actually need to have 5 lessons before we can get to that lesson. And why is that? Well, because while lawyers and law students excel at logic and argumentation, they completely lack programming, grammar, syntax, and computer science design principles. You can't just jump straight into coding a complex agreement. You have to break things down into absolute raw primitives first. Before you can even touch a smart contract, you need to understand what a string of text is, what a numerical integer is, and how a true or false Boolean value works, just to ground all that legal jargon in actual computer science. Which brings us to Section 4,
Decoupling logic from data.
Let's talk about the linguistic hurdles here. The very first one is literally just how we read. Lawyers have to completely retrain their eyes. In normal English prose, we naturally read from left to right. But in coding, when you're assigning a value to a variable, you actually read the statement right to left. So for example, instead of saying the rent is $500, in code, you're effectively saying $500 is assigned to the concept of rent. The logic of the execution is completely distinct from the material being processed, and learning to separate those visually is a massive adjustment if you're used to standard paragraphs.
And that leads directly to a huge grammatical trap for anyone crossing over into computational law, confusing association with equality. A single equal sign means association. You are assigning a value to a variable. You're taking a value and putting it into a container. But a double equal sign, that means equality. You are checking if two distinct values are exactly the same. Confusing these two will completely break your legal runtime. If your contract is supposed to check if a payment equals $500, but you accidentally assign the value of $500 to that payment variable instead, your entire system is suddenly acting on false premises. It's a massive conceptual gap.
And once you master equal signs, you hit an even bigger philosophical wall, the and/or trap. In traditional legal drafting, ambiguity is actually a feature, not a bug, right? Lawyers constantly use phrases like and/or to provide wiggle room or cover unforeseen circumstances. But when you map contracts into nested conditional code, like if-else statements, that ambiguity is fatal. Strict Boolean logic requires absolute deterministic true or false gates. There is no maybe. If you force vague legal scope into a strict runtime, the whole logic just collapses. And a collapsed logic gate in a computational contract could mean assets are frozen indefinitely because the system literally doesn't know how to proceed. You absolutely must decouple the machinery of execution from the data itself. To truly see this decoupling of instructions from data, compare a static Google Sheet to an active JavaScript script. A single data entry, like a person's name or a currency amount inside a spreadsheet, is totally passive. It's just sitting there waiting for a human to read it. But that exact same piece of data inside an active JavaScript script behaves completely differently. It's no longer just text. It becomes a dynamic primitive, a string or Boolean, that actively drives the machinery of the execution. The data itself actively triggers the next step of the performance. So how do we build future-proof legal systems that don't just break the second the law changes? We look back to the 1980s. The Unix philosophy is the principle of writing modular programs that do one thing perfectly and communicate with each other via simple text streams. Treating text as the universal interface is the ultimate foundation here. Why? Because pure text never becomes obsolete. A system built on heavy proprietary software, it's eventually going to die. But a system that passes pure text from one small, focused program to another will literally last forever. It's exactly why we can build incredibly powerful modern AI chatbots and clean JSON-based legal records today. It's all just modular text streams gracefully talking to each other across decades of technology.
All right, finally, Section 5, the 3 stages of law.
Let's zoom out a bit and look at the macro evolution of the entire legal profession. I love this transportation metaphor from the source material. We started in the analog horse and buggy era of lawyering. Very direct, manual labor, drafting documents by hand, physically moving paper from desk to desk. Today, thanks to legal engineering, we've entered the mechanized car stage. We're moving at hyperspeed with document automation and AI drafting. But just like early cars, this high-speed environment requires entirely new regulatory guardrails. We're going to need modern negligence torts and fresh legal frameworks just to keep us safe when our mechanized tools inevitably cause damage. And eventually, we are heading toward automated Waymos, fully autonomous, self-executing legal systems that handle the runtime entirely on their own. So where do you fit into all of this? The sources identified 2 distinct career paths going forward. First, the engineering path. This sees developers acting as specialized legal authorities, kind of like patent agents do today, writing and managing the highly complex code under the hood of these systems. Then there's the lawyering path. This sees traditional practitioners naturally adopting programming syntax over time, simply because the final legal deliverable is no longer a stack of paper, it's a piece of executing software. Now, neither path is wrong, but both of them require entirely shedding that old static paper mindset. Mastering this new computational syntax, it's inevitable. Which leaves us with this final, provocative thought. The legal world is undeniably shifting from passive reading to active executing runtimes. You are no longer just a drafter. You are becoming a composer of complex systems. So ask yourself, When will you stop writing static documents and start orchestrating the legal performance of the future? Thanks for joining me on this explainer, and I'll catch you in the next one.